warning system, each of a shark's senses locks on as it approaches its prey. With well-developed inner ears, sharks can pick up sounds from up to 1,700 yards away. Sound actually travels better and further in water than air. And experiments have shown that sharks are particularly attracted to lower frequency sounds, like the ones made by this speaker. Irregular vibrations with frequencies at or below 40 hertz incite a frenzy among these gathering sharks. Not surprisingly, that's the same frequency and sound pattern emitted by a wounded fish. As the shark closes within a few hundred yards of its eventual meal, the sense of smell takes over and guides it ever closer. Sharks pick up a scent in much the same way as dogs, by moving back and forth to stay on the trail. A shark is capable of picking up a single molecule of blood in over 1 million molecules of water. The apparatus responsible for smell is located in 2 nostrils near the front of the snout. As the shark swims, odor-laden water is forced into its nostrils and over delicate sensory tissue. From about 100 yards, sharks can begin to detect even the faintest vibrations created by the movements of struggling fish. These vibrations are picked up by very sensitive fluid-filled canals called lateral lines, which run under the skin. Lining the canals are tiny hair-like receptors which are especially attuned to the kinds of vibrations made by wounded prey. At around 30 yards, the hunter can literally set its sights on the hunted. The size and shape of shark eyes tends to depend on where the shark lives. Sharks that feed in shallow waters usually have smaller eyes because they have more light to deal with, while sharks that swim in deeper water tend to have larger eyes. Some sharks also have an eyelid called a nictitating membrane that closes to protect the eye while the shark bites its prey. By the time a shark gets within 6 feet, it can even detect prey that is hidden from view. It does this with sensory organs known as the ampullae of Lorenzini. Connected by pores located on the snout and head, these jelly-filled sacs are capable of detecting electrical fields as well as the direction they are coming from. These fields can even emanate from a tiny open wound or an animal buried in the sand, and can be as weak as 100 millionth of a volt. Any one of a shark's highly tuned senses is capable